In the name of Allah, in this lecture, I will talk about how to choose the correct cross-section area for the neutral cable and the earthing cable. After choosing the correct cross-section area for the main phases R, S, and T in square millimeters, we must determine how to select the correct cross-section area for the neutral cable and the earthing cable. It is important to consider whether the electrical loads are three-phase or single-phase. For example, if we have a three-phase motor, it requires all three phases, R, S, and T. On the other hand, if we have a single-phase motor, it requires only one phase, R, S, or T, along with the neutral. For a three-phase load, we use only the three phases R, S, and T without the neutral. Since each of these three phases carries the same current, the load is considered balanced, meaning that no current flows through the neutral, and the neutral current is zero. However, for a combination of three-phase and single-phase loads, such as in a distribution board, we have three phases, R, S, and T, plus the neutral. In this case, if the three-phase loads are balanced, each phase carries the same current, resulting in a very small current flowing through the neutral, meaning the neutral current is low. On the other hand, for single-phase loads, we only use one phase, R, S, or T, along with the neutral. Since the current in each phase varies and does not carry the same value, the load becomes unbalanced. This results in a significant current flowing through the neutral, meaning the neutral current is high. Finally, for electronic loads, these loads generate current harmonics in their phases, R, S, and T, such as the third harmonic. This means these loads are unbalanced, resulting in a high current flowing through the neutral cable due to the harmonics. Therefore, before selecting the correct cross-section area for the neutral and earthing cables, we must first understand the type of loads we are dealing with. For example, as we can see, three-phase cables or multi-core cables contain three-phase conductors, R, S, and T, along with a neutral conductor and an earthing conductor. To choose the correct cross-section area of the cable, whether the configuration on the left side or the right side is appropriate, we must consider the type of loads connected to the system. First, if the loads are mostly three-phase balanced loads, such as three-phase motors or large industrial equipment, then the neutral current will be very low. In this case, the configuration on the left side is suitable, where the neutral conductor has half the cross-section area of the phase conductors, 70 square millimeters for R, S, and T, and 35 square millimeters for the neutral and earthing conductor. Second, if the loads include single-phase or electronic loads, these loads can create an unbalanced system or generate harmonic currents, particularly the third harmonic, which accumulates in the neutral. This results in a high neutral current, requiring the neutral conductor to have the same cross-section area as the phase conductors. In this case, the right side configuration is the better choice, where the neutral conductor has the same cross-section area as the phase conductors, 70 square millimeters, while the earthing conductor remains 35 square millimeters. Conclusion: if the system consists mainly of balanced three-phase loads, choose the left side configuration, neutral at half the phase conductor size. If the system contains single-phase loads or harmonic generating loads, choose the right side configuration, neutral same size as phase conductors. To make the final decision, analyze the load distribution and check for significant harmonic presence in the system. In the previous lectures, I explained how to choose the correct cross-section area for the main phases R, S, and T by calculating the load current, thermal current, voltage drop, and short circuit parameters. After selecting the appropriate cross-section area for the main phases R, S, and T in square millimeters, the next step is to determine the suitable cross-section area for the neutral and earthing cables. As shown in the table in front of us, the correct steps for selecting the cross-section area of the neutral conductor are as follows. First step, if the loads are electronic loads or any loads that generate significant harmonics, the cross-section area of the neutral conductor should be the same as that of the phase conductor. Second step, if the cross-section area of the phase conductor is 35 square millimeters or smaller, the neutral conductor should have the same cross-section area as the phase conductor. Third step, if the cross-section area of the phase conductor is greater than 35 square millimeters, the neutral conductor should have half the cross-section area of the phase conductor. As shown in the table in front of us, the correct steps for selecting the cross-section area of the earthing conductor are as follows. First step, if the cross-section area of the phase conductor is 16 square millimeters or smaller, the earthing conductor should have the same cross-section area as the phase conductor. Second step, if the cross-section area of the phase conductor is 25 square millimeters or 35 square millimeters, the earthing conductor should have a cross-section area of 16 square millimeters. Third step, if the cross-section area of the phase conductor is greater than 35 square millimeters, the earthing conductor should have half the cross-section area of the phase conductor. Thank you for your attention. See you in the next lecture.